My name is Stephen Alonso, and I'm a flat Earth scientist. I'm pushing the boundaries of where modern science has failed. I'm going where no one else before me has gone.
Dr. Stephen Alonso here with the Flat Earth University, and today we're going to talk about the dimensions of our flat Earth. That will be the diameter and the circumference along with the radius. This allows us to determine the total surface area and also have a quantifiable model that we can discuss about. This was brought up to me when I was seeing some posts in Facebook groups by Globers who are asking this question. Going back to the previous video I did, Globers do not understand the flat Earth model, and they may not even understand the foundations of math and geography enough to be able to perform these calculations themselves. Another problem was in the responses. No flat earthers were answering the question when you all should. Now, this is partly due to junior flat earth groups such as Nathan Oakley's, where these types of discussions are not allowed. He doesn't want anyone to make claims, he doesn't want to have a model, and that ultimately keeps you at the junior level, where my goal is to help you become a senior flat earth researcher and be able to confidently answer these questions. Now we're going to have a quick introduction again. You can skip to the part where we begin this presentation. But I'm going to be starting all my videos now, which is a quick few-minute introduction about life, what I'm up to, and everything. So right now, up top there, I have the gym supplements I use. A pre-workout, protein powder, and creatine. A pre-workout is very similar to an energy drink, but it has a whole different spectrum of chemicals. For example, beta-alanine. This helps your muscles recover between sets. It'll have stuff like alpha-GPC, which is a nootropic. It affects your neurotransmitters in your brain, dopamine, for example, so that you can be focused and motivated to work out. So if you're like me, you might have a busy life and sometimes you're tired and you might not want to go to a gym. If you drink a pre-workout, you're going to be all amped up, full of energy, ready to go to the gym. So I'm very cost effective would be the best term. So this pre-workout up there is on Amazon and it's very cheap, but the ingredients are exactly what you need for an intermediate level pre-workout. The next is protein powder. Now I use unflavored whey protein. I don't like the sugary stuff, the artificial sweeteners, and I literally just mix it with water and drink it. You're not doing this for fun, you're doing this for nutrition. Now, if you really don't like the taste, you can get flavored whey protein powder. The same company, for the same cost up there, has vanilla, and it also tastes amazing in water. And the final ingredient is creatine. Now, what creatine does is it gives your muscle, well, actually not just your muscles, it gives every cell in your body extra ATP. This is adrenaline triphosphate. Your cells use this as a source of energy. And at the gym, this may be the difference between being able to do 11 reps and being able to do 12 reps. Now, these 5 to 10% improvements really do matter long term. And if you're like me trying to gain muscle as effectively and as fast as you can safely do, you want to have these supplements. They really help you. Now, you might have noticed how I cut myself off when I was saying it gives your muscles more energy, because it actually gives every cell in your body more energy, including your brain. So the adrenaline triphosphate that goes to your brain does help you perform quicker and knowledge-based tasks. So I'm a software developer for my day job, and having creatine in my body really does help. Now with creatine, it's not the same as something like caffeine, where it wears off in 4 hours. Creatine is something that saturates in your body, meaning that you're not even going to feel it for the first 2 weeks. You got to take your 5 grams every day, and then after 2 weeks, your body now has creatine saturated in it, And that then allows you to have a 24/7 effect. This is something constant that happens. Similar to some of the chemicals in pre-workout like beta-alanine, it also saturates. So these are stuff that happen over long term where you just become a more optimized person. Now, last night in Belize, we had some rain, which was exciting for me because I bought grass seeds to replant my yard. I have a 1 acre lot, which is a pretty good size, and I love it because I'm just surrounded by nature, jungle, and trees. But over the last few years, the grass started turning brown and dying off, and it just doesn't look as nice. Another reason is that I also farm. I'm involved in many hobbies and my life's quite interesting. So I have sheep. Right now I have 5 sheep that are walking around my property eating grass, doing their thing. And I recently got a new baby sheep. This was on New Year's Eve actually. I wandered outside and saw a little, like, it looked like a black cat and it was dark and it was hard to tell at first, but no, it was a cute little sheep. And farming is just so much fun. I do ducks, chickens, and sheep, and ducks are really nice. You can't really buy the meat here in Belize. So for me, I'll butcher it myself. I do a kosher method of slaughtering, and it's amazing, really high quality meat that is worth doing. The chickens are more just for fun. I don't really butcher them anymore because chicken here is just so cheap. Like I think 1 pound of mixed chicken pieces would be the equivalent of like $1.80 US a pound. So very cheap and affordable. Now, that's for the introduction. Now let's get into what we're actually talking about. So when we're talking about the diameter, this is the distance directly across of a circle. The radius is the distance from the middle point to the end. And when we're talking about circumference, that's the total distance around the firmament, you could say for this example. Now, latitude is not debated amongst flat Earth or the globe. We know that for every degree of latitude you travel, that is going to be equal to 69 miles. Going from the North Pole to the equator, that would be 90 degrees of latitude. And then if you continued from the equator to the South Pole, that would be another 90. So we know that from the North Pole to the South Pole, there's 180 degrees of latitude. Now let's bring up the flat Earth model so we can actually show what I'm talking about in a little bit more detail. Let me just refresh this so it's not going to lag out. So right down there is our North Pole. So from there to the red line here, which is the equator, that is 90 degrees. And from the equator going over to the South Pole, that's another 90 degrees. So the distance from the North Pole to the South Pole is 180 degrees. Now this is very basic math. You would then just multiply, for example, 180 degrees times 69, and you end up with 12,000 miles, 12,420 miles. That is the radius there. And then consequently, if you wanted to get the entire diameter from one South Pole going straight across to the other end, so from over there to over here, that would be 360 degrees. Multiply that by 69, and you get double what we previously had, 24,000 miles, 24,840 miles. This is not too debatable, and we should all be able to understand this. This then allows us to use formulas such as the circumference of a circle. I have my notes right here. The circumference of a circle is 2 pi r, r being the radius. Now, the radius is the distance from the North Pole to the South Pole, and we established that that's about 12,000 miles. This then allows us to use the circumference formula to determine that the total distance around our flat Earth is 78,000 miles. Now, we can also use an area formula. For a circle, that's pi r squared, r again being the radius, so 12,000 squared, multiply that by pi. You get about 484 million miles squared. Miles squared means we're talking about a surface area. For example, my 1 acre yard or a square foot. So we're talking about a unit of area. It's not just a distance anymore. So that's what that squared means, if that was confusing to you. But 484,000 miles squared. That is the total surface area for our flat Earth. And this should be quite easy to understand. Now, when we're going back to the flat Earth model, there are some simple observations that we can also do to confirm that there is going to be, for example, 90 degrees from the North Pole to the equator. The easiest one is going to Polaris. So let me increase the size of the font here so that it'll look bigger and clearer in the video. Now, this red dot at the top of the observer, that is the North Celestial Pole, which for our purposes represents Polaris perfectly. Now, as the observer would move away from Polaris, you're going to see that that red dot drops. And this should be very well known to a lot of you. So if you're in the United States with a latitude of 50 degrees, Polaris will be 50 degrees of elevation from your observer. And this one-to-one relationship holds true because the Earth is flat. You can determine where your latitude is by simply looking at Polaris. Now, as we go to the equator, you'll see that Polaris approaches zero. So see now how we're at 0 degrees of latitude. The observer is on the red line representing the equator. Polaris can no longer be visible. Now, when I coded this model, I increased the height of the observer to make it easier to understand, but that is elevation 0. You would not actually be able to see it. And consequently, if you were to continue going south, as you know, the flat Earth model also has a south celestial pole. You can actually see the Southern Cross stars right here. But as you would continue going south, that starts rising again. So the south celestial pole, you can determine that by doing an X between the Southern Cross and another star. That will also rise up right up to 90, just like what happens with Polaris. So from an observer-centric framework, you can easily determine that there absolutely is going to be 180 degrees of latitude for the radius of whatever map we even think we live on. So this doesn't even have to do with the assumption that we live on the North Polar projection, the Gleason map. This is just something you can do looking outside, and you can determine yourself that, yeah, okay, there's 180 degrees of distance being traveled. You multiply that by 69, because again, you can do this yourself. If you're in the United States at 50 degrees of latitude, go to 51 and just measure the distance. It's only 69 miles. This has been done for thousands of years. Flat Earth celestial navigators use these techniques when they're lost at sea and need to find how to get to a different place. Now, this should make a lot of sense. I hope I explained this quite easily. I don't really know if there's too much more to discuss covering that. So to reiterate, the distance from the North Pole to the red line of the equator is 90 degrees of latitude traveled, about 12,000 miles. Continuing to the South Pole, that would be another 90 degrees, meaning about a 24,000 mile radius. The diameter would be the entire distance, so that would then be 24,000 miles. And then you just plot this into surface area formulas, circumference formulas, and we know then the distances of our flat Earth. Thank you for listening to this presentation.
What is flat Earth science? Well, it's asking the questions other people are too afraid to ask. It's the willingness to face any challenge, knowing that failure is how we get better. It's about testing our hypotheses using first principle concepts.